Hi, this is Derek here again with Tater Tot Academy. We're going over algebraic linear equations. This is chapter 3 in the purple book, so it's a good test review for you guys. Let's go ahead and get started. So some of the problems we'll be working with are just, they kind of look funny, they look scary, they're big. So we'll look here. We have 3x over 4 minus 2x plus 1 all over 4 equals negative 1.5. One of the most important things we can do to make this easier for you is to get rid of the fraction. So what I'm going to do is I'm going to multiply this whole thing, the entire equation, by 4, because I see the common denominator of 4, and this is over 1, would be 4. So now when I multiply the 4 and the 4, they will cancel, and I'll end up with just 3x. The 4 and the 4 here will cancel, so I will minus 2x plus 1. And this I will multiply by 4 to get negative 6. So all I did was distributive property. I went here, and I went here, and then I went here. I did my distributive property on all three things. Now I need to combine and finish up any math, but I do see I have another set of distributive property. That negative is a negative 1. So now I'm going to distribute that to both places, and I end up with 3x minus 2x minus 1 equals negative 6. Now I'm going to go ahead and combine like terms, so 3x minus 2x is x. And then I'll add 1 to both sides, add 1 to both sides, it equals negative.
The precision blades are the same, but shaving.
Well, that was a strange interruption. Sorry about that. We'll go ahead and continue anyways. So that's x equals negative 5 for our final answer here, so we're good to go. Next one, same basic idea, but now we're dealing with decimals. So let's go ahead and do our distributive property. And 0.6 times 1 is 0.6. 0.6 times negative x is negative 0.6x. Okay, next, this is a positive 2 as I see. So I'm going to multiply positive 2 times x, and I get positive 0.2x. And positive 2 times negative 5. Ooh, that's kind of hard here. But that comes out to be negative 1 equals 10. Let's go ahead and put everything together that I see, and I see some like terms right here. That's a negative 6x and a positive 0.2x. So when I put those together, I have a negative 0.4x. I have a 0.6 and a negative 1. That'll be negative 0.4 equals 10. Well, if we see this, I'll add 0.4 to both sides. I will add 0.4, and I get negative 0.4x equals 10.4. Not the easiest thing to look at, but I can just pretend that if I multiply both things by 10, I'm 4 into 104. Let's go ahead and do that out over here. Because when I divide each side, by negative 4, divide by negative 4, I'll see that 104 divided by 4 is 2. That is 8. And I'm left with 24, which is 6. So x equals negative 26. I know I went kind of fast. Hope you saw that I can just move over those numbers just to make my life easier, but it wouldn't have mattered if I divided by the decimals. It would have worked the same exact way. Let's go ahead and go to the next one. For any of you that have tuned in before, you know I go very quickly on these. That's just because I want to be able to get through as much as possible, and you can stop and rewind whenever you need. Okay, so shoes cost $60 more than pants. The ratio of the cost of pants to shoes is 1 to 3. What was the cost of the pants? Well, let's look at this. So I have that we have a ratio of 1 to 3 of shoes to pants. Okay, so, let me go ahead and do it this way. So I have shoes is going to be 1 block, and that is shoes. Now I'm going to do pants is going to be 1, 2, 3 of those. And let's go ahead and 1. And this whole thing is pants. All right, so we've got that much. We've got our shoes and we've got our pants. Let's go ahead and jump back. Okay, we know that shoes cost $60 more than pants. So shoes cost $60 more than pants. And let me make sure, I might have mislabeled this by mistake. I did. Sorry, I wasn't looking at it when I was writing this. So we know that shoes cost 3 times as much as pants. So this is my shoes. Sorry, that is my pants. And these are my shoes. There, now I got it right for you. Sorry about that. It says that shoes cost $60 more than pants. So $60 more than pants is my shoes. That means that much should be $60. That means that each block is $30. That means that pants are $30. Just because we know the equal parts. It's 4 parts. 1, 2. So this is part 1, 2, 3, and 4. And I know all 4 of those are the same because it's a ratio. So when I broke this all up together, I realized that each part was $30. Let's look and see what the actual question is. It says, what was the cost of the pants? Well, we jump back here in pants. We know that pants equals $30, and we're good to go. Boom. Okay, let's move on to our next word problem. So Alex earns 2.5 times as much as Gary in a day. James earns $18 more than Gary a day. If all three earn $306 a day, find Alex's salary per day. So Alex is 2.5 times as much as Gary. So we have, whoops, let's go ahead and give us this. So I have G equals Gary. Let's go back. And we know that Alex earns 2.5 times as much as Gary. So 2.5G equals Alex. Let's go back and check out the rest. It says that James earns $18 more than Gary. So G plus 18 is James. And we also know because they told us that Gary plus Alex plus James equals, oops, it's hard to squeeze it, but equals 306. They told us that Gary, Alex, and James was $306. Well, if you look now from the chart we made where G is Gary, 2.5 G is Alex, and G plus 18 is James, I can just combine these three things. And I can say that G plus 2.5 G plus G plus 18 equals 306. Go ahead and use this as a solving time, and I see I have 4.5 G's plus 18 equals 306. I get minus 18 from both sides because I need numbers on one side and variables on the other. So we see this is 4.5 G equals, we subtract that away, and I got 296, and that's 288. And now I just have to do my math here. Because, we see that I got to divide by 4.5. Sorry, I didn't show that. But now we have to do our math and go 288 divided by 4.5. Any of you that aren't good with your decimals yet, we got to remember that we move the decimal spot 1 point. If I do that, I got to move this decimal point 1 spot, add a 0, put my decimal up top. Now I need to look and see how many times 45 goes into 28. It doesn't. Into 288, we can look at that and say, hey, that's probably going to be 6 times. I might be off. If I am, oh well. We'll start and go to lower. 6 times 5 is 30. Put my 3. 6 times 4 is 24, and 3 is 27. Nope, we hit it on the nose. Perfect. We got 8 here, a 1 here. Bring down the 0. Now we got to see how many times 45 is going to go into 180. That will be 4. So we know that Gary's salary then, because it's G, so we know that G equals G equals 64. So if Gary makes 64, that means he is at $64. Well, it says Alex is 2.5 of Gary. So then I'd have to go 64 times 2.5. Okay, and I'll go ahead and do that out. But I can do this mentally also and say 128 plus 32 is 160. So I hope you saw that I doubled the 64 to get 128. And then I took half of 64, which is 32, to give me 160. Now James says he has $18 more than Gary, so that's 64, 74, $82 for James. Let's go back and see what the actual question asked. And the question says, find Alex's salary per day. So we would say Alex earned $160 per day. Let's move on to the next one. Oh, this is great. Here we get one where we have to really pay close attention to our negative signs, and we have to pay close attention to the bottom of our fractions. So first thing I'm going to do is multiply everything by the common denominator of 6, 4, and 3 we'll see is 12. Okay? Now remember I'm doing distributive property. When I do it in the first one, that means 12 divided by 6 is 2. So I'm actually going negative 2 times x plus 1. Here on the next one, 12 is going to go here, but 12 is being divided by 4, so that's only 3 left. So that's negative 3, because I do have that negative sign. I did have this negative sign over here. So negative 3 times 5 minus 3x. Then in my final one equals, I'll put the 12 here, and 12 divided by 3 is 4 times 1 is 4. Let's go ahead and do our distributive properties now. Negative 2x minus 2 minus 15 plus 9x equals 4. Next up, let's combine like terms. So I see I have a negative 2x and I have a positive 9x, so I have 7 x's. And here I have minus 17 equals 4. Continue here, add 17, and I get 7x equals 21. And hopefully all you can see is I divide by 7. I divide by 7 and get x equals 3. Okay, so we ended up with x equals 3. Hopefully you can follow all those steps. Let's move to the next one. Okay, here we're trying to convert decimals into fractions. We know the rules. If I have repeating start from the beginning, so 0.5 of the line means the same as 0.55555 forever. So whenever it's over, it repeats from the beginning, it's over that many 9s. So that's one spot that's repeating, so I will go 5 over 9. And this shouldn't say, I'm changing the number here to 0.89. Okay, so on this one, it says 0.89 repeats forever. So that's 0.89, 89, 89, 89, repeating. Well, once again, the repeating starts from the beginning. I have that many 9s underneath it. So if it's 0.89, then that would be 89 over 99. As for these, when the repeating does not start at the beginning, I have to do this in 2 steps. First, I got to find out how many spots would go to the end of the repeating. This is where repeating ends. So that would be 83 to where the repeating ends. I had to move it 2 spots. That means I need 2 zeros. So I will say equals 100x. Next step, I'm going to go to before the repeating. So here's right before the repeating started, is right here. So that would be the number 8 equals, if I look at this, I had to move 1 spot. I needed 1 0. So I'll say 10x. Go ahead and bring this over. And I subtract everything out. Now I'll go 83 minus 8 is 75 equals 100x minus 10x is 90x. This I'll solve just like I would anything else. Divide by 90. Divide by 90. And I'll get x equals, hopefully you can see that I can divide all these by 5. If I divide by 5, I got 15 18ths. Now hopefully you can see I can divide both of those by 3. That will be 5 6. So my answer is 5/6 equals, this whole thing equals 5/6. So 0.83 with the 3 repeating, 1.83333 is equal to 5/6. The repeating decimals do get kind of tricky. Hopefully you've looked those over a bunch, but there is a quick way to get that done. All right, and this next thing, I have 3 different kinds of equations. I've got no solution, I've got infinitely many solutions, or I have 1 solution. A no solution means I have x's that match and numbers that don't. So if I said 3x equals 3x plus 5, well, I can never have 3x. So that'd be x, we're going to say, is boxes of crayons. So if I have 3 boxes of crayons, I can't have the same amount of crayons as someone that has 3 boxes of crayons plus 5 extra crayons. So that means there's no solution. There's no way I can make those 2 equations ever match. They will never be the same. When this ended, if I subtracted 3x from both sides, you can also see if I go down all the way, it ends up with an untrue statement of 0 equals 5. That's an untrue statement. It does not work. Infinitely many means no matter what I put in will work. So here I'm going to say 3x plus 5 equals 3x plus 5. This says that if I have 3 boxes of crayons plus 5 more, and you have 3 of the same kind of boxes of crayons plus 5 more crayons, then we're both always going to have the same. No matter what amount of crayons we say are in each box, as long as they are identical boxes, we're always going to have the same amount of crayons if we have the same. So if I do this out and I subtract, I could say minus 5, minus 3x minus 3x, and that would be 0 equals 0. So if at the end I have that's a true statement when I'm done. 0 always equals 0. Or if I see that my x's match and my numbers match, it's infinitely many solutions.